Hi everyone, we are
Jacob, hello.
and Mikołaj from Golem Factory in Warsaw in Poland, and today we're going to entertain you by building and running WebAssembly modules on Golem network in
Yeah, cool stuff.
distributed way. So this session is intended for developers. I suppose we can call ourselves developers.
Well, I'm trying to be one.
Well, yeah, but at least you started at some point, so did I. Do you remember how it all started?
No, it was ages ago. No, wait. Yeah, it was in Pascal, actually. I remember, unfortunately, yes.
Unfortunately.
Yeah.
Well, I started on an 8-bit PC in BASIC. Then I picked up some other languages along the way, but every time I picked something new, it was actually exciting and thrilling just to write something up, debug all the syntax errors, and then compile and run and see something coming out of it. That's pretty exciting. I'm saying this because we hope to replay this thrill and excitement with some of you guys if you wanted to try this out and try this new platform.
Yeah, sure. I hope you're going to enjoy it. It's a lot of fun.
So, we're going to be playing with WebAssembly. Just to remind everyone, WebAssembly, it's dubbed as the assembly language for the web.
Are you for real?
I know
Really?
it's a bold statement, but seriously, it is a platform. It is a development software platform designed as the native platform for the web, and it comes with a couple of interesting features or aspects. It offers near native performance. It comes with a compact binary format, makes it efficient to actually distribute it on the web. It can be compiled from any language, and this is actually an important feature because in theory you can write software in any language you want, things like C++, or we're going to be using Rust today because that's both
Rust is cool!
with one of the best supports for WebAssembly.
Right,
WebAssembly is portable. It can be distributed in packages and run on different platforms. It comes with a cool sandboxing model, which people know from JavaScript, which makes it controllable when it comes to running it on different hosts. And similar to JavaScript in one other aspect as well. I mean, just as JavaScript used to be a browser platform, but then it broke out of browsers and started being used in backend server-side applications, like with Node.js, for example.
That's correct.
In the same way, WebAssembly doesn't need to be run in a browser. It can be run on a server side. And this is exactly the scenario which we are going to be demonstrating today. And we will be using Golem infrastructure, or Golem network, for that. And I suppose some of you came into this clip following the Golem buzzword. And for those of you who hadn't, Golem is a concept of a decentralized marketplace for computing power, computing resources, which enable you to share your computing CPU cycles in a peer-to-peer network and in exchange for crypto tokens. The interesting, convenient feature for us here is the fact that Golem, starting from release 0.21, it supports WebAssembly. We call this gWasm support, so we run WebAssembly modules, we call them gWasm packages. And for today, I think we're going to be using the version 0.22.1, which is the latest stable for today. For those of you who either had been to DEF CON 5 in Osaka or who watched the footage from our session in Osaka, we did run that workshop back there with a slightly different content. Back then we used Golem Unlimited as the infrastructure. That was convenient to us back then because it allowed us to set up our own controlled, secure environment for the workshop. But for this session, for this recording, we're going to be using Golem Mainnet. So this is the real thing. Yeah,
that's the real deal. Yeah, that's exactly what it is.
Anyway, also to add some flavor and mood to the workshop, we actually put some background story to it, and it became almost a little role-playing game. We thought it was cool. We liked it. It was
Yeah,
fun running
it was a lot of fun.
and we felt actually we would replay some of it. At least we tried to play along some of that story today. So here it goes.
Let's do this.
So we are in year 2077. We are in, assuming that we are in Osaka. We are in this world of not so distant future, and we are at war because we are a movement of crypto resistance, defending the free world from the oppression of crooked, corrupt, technocratic syndicates and corporations. And right now we are celebrating our annual conference of the greatest visionaries and thinkers of the free movement, and a conference such as this is obviously a threat to the syndicates. Our intelligence is telling us that our location has been compromised, and we are likely to become the target for attack. And we expect long-range cruising missiles to be launched from private silos in the private islands in the Pacific Ocean. But we are not defenseless. Okay? We are the crypto resistance, we have our wits, we have our technology, and we will...
we have Golem.
We have Golem, we will take a stand, we will protect ourselves from the attack. So hopefully you're going to join us today, because we're going to be doing this using WebAssembly.
Yes, and Golem.
And Golem. Okay, so the agenda for today is, okay, so Kuba here will actually run a live coding session. So he'll be writing software in Rust. He'll be running or compiling this into WebAssembly modules. And then he will be using the gWasm runner utility, which the Golem factory had prepared. And it's a utility which simplifies deployment and execution of WebAssembly modules in the Golem, on the Golem infrastructure in general. So not only Mainnet, but also Golem Unlimited. Okay?
That's correct, yep.
Off to you.
Okay, perfect, right. So before we start, so our camera operator, brilliant Jacek, prepared very good docs. You can't see him; he's actually dancing right now. So you can actually browse through the docs as I'm going through the tutorial, and everything is actually described there. What you need to install, etc., etc. So if you get lost, obviously you can pause because now it's not live, and rewind. That's cool, but you can also read through it as well. So without further ado, we're gonna start off with a very simple app, which is essentially a hello world called Hello gWasm Runner. Ta-da! But before we get on to this, let's very briefly recap what the API is about. Now, the API is very simple. It consists of 3 functions that you have to specify the logic for if you want it to be run on Golem using gWasm Runner. So we have split, exec, and merge. Now, for a keen observer, you can actually notice that this kind of looks like MapReduce, and it's no coincidence. It's meant to be like MapReduce. So in split, you basically you specify the logic for how you want to split your input problem into tasks. And now each of those tasks is going to be then computed by a node. So in this case, a provider node on the Golem network. Okay, so split is done locally. Then each task ends up at the provider node, and then the logic that you specify in exec step is the logic that they're going to use to compute this bit of the task. Okay, super simple, and that generates the task result. Now all of those task results then come back to us, and then in the last step called the merge step, we basically, you do something, combine them into the final result. So as I was saying in the Hello gWasm Runner example, we are going to do something very simple. I'm pretty sure this example is a standard example for anybody playing with MapReduce. So we are going to pick an array of 100 integers, and then we're going to compute its sum. But we're not going to do it, well, typically like you would do, like summing numbers one by one. We're actually going to split it into subarrays, send them to Golem nodes. They're going to do their sums, and then we're going to sum up the resulting sums. That's a lot of like indirection. I know, but it's actually very simple. There is no magic there, okay? So everything is online. It's on our GitHub. under Golem factory / hello GWASM runner. So feel free to browse, feel free to fork, to break, to play with.
By the way,
do whatever you like.
By the way, all the links to all the content that we are presenting they are also presented in the
the description
for the
right.
clip. Yeah.
Yep. Exactly. Okay. So let's do this. Right. So I've got everything cloned. I'm prepared and stuff. Unlike like 2 cuts ago when I wasn't, but now it's fine. Right. Okay. So so this is the basic structure of the main program here. We have the main with the dispatcher run. This is the technicality that actually allows you to actually put everything together. Then, as you can see, we have split, exec, and merge. As I was saying, our task is basically
100 integers.
Right. So a vector of U64s. The task result is the sum, so just one integer. And we're going to populate split, exec, and merge. So in split, first things first, we need to decide how many subarrays we want. Now, I'm kind of getting ahead of myself here. In Rust, when you split or when you generate chunks from a slice, you need to specify the size of the array, not the number of slices. So I suggest 50. So that's going to give us two tasks, which I think is perfect for this occasion. Just 2 tasks on Golem,
simple
pretty
enough.
quick. Yeah, exactly. Right. So pardon me. So this is usize, and that's going to be 50. Okay.
Usize or use? Oh, sorry. Yeah.
Yep. Now the input array, I suggest we do 0 to 100 exclusive. So that's 0 up to 99 inclusive. Okay. And just connect it. That's fine. Okie doke. Now we need some kind of an accumulator, so some kind of an array that we are going to collect the tasks into. Okay. Now you'll notice here that instead of writing a vector of tasks, I wrote vector of one element tuple, of which elements are tasks. Now that's a technicality that is because of the constraints in the type system, in the trait system, I guess, for Rust. But I'm not going to go into in detail why it's like this. But if you're interested, feel free to ask us or have a look at the source code. Everything is there. Okay, so for chunk, so this is the bit where we're actually gonna split the original array into subarrays. We have array and chunks, and then array size, and then so our task is going to be chunk to vector, and let's push it in to our accumulator here and return it. And that should be it. Okay. Now for exec, that's even simpler. So this is the logic this is the logic that's being done by each node on the network. This is as simple as basically calculating the sum of the resultant task. So we just do task into iter and then sum and then return it. Again, remember about those tuples. This is very important. And finally, in the merge step, we actually get a vector of
U64s.
Well,
or the task results.
Right, but actually we get task result paired with an actual task, so an actual input as well.
Okay.
So you can actually do some pretty cool stuff because then you can track ordering and stuff of the results that you got from the nodes. In this case, we don't care. So all we're gonna do is essentially extract the task results in whatever order there is, and just compute the sum. That's it. Okay. So let's do just that. So task result is going to be a vector of task result. So results into iter map. As I was saying, we first of all don't care about the first result, and result, extract it, and collect it. Okay, and then let's sum them up. So task results into iter sum. Perfect. Right. So here we need to annotate the type. Now, to actually compare it to something, let's do the same thing locally on our machine. So we're just going to sum it up directly. And then finally, so we're going to assert that the given result is equal to expected. Now, if they're not, then the code will panic and we'll see it. But if it will be okay, then we won't see anything. So we might as well add a println afterwards, which is only ever going to be reached if given is equal to expected. Okay, cool. Right, okay, I think I have a typo somewhere here. Because it doesn't like it. You need to help me here, I can't see it.
Oh, sorry.
Oh,
you want to take the
results,
result? Yeah.
Right. Cool. Sorry, typo on my end. Okay, cool. Right, I think we're ready. So let's build it. Ta-ta-dum. Should be like drums or something. Okay, so before we actually start running that on actual Golem network, let's do it locally first. So this is a perfect way of verifying without actually
spending cash.
Exactly. Whether you have correctly implemented the logic. Obviously, for big problems, that can be difficult because you don't want to run it locally. I mean, why would you if you want to run on Golem something that has to be really, heavy?
But you
can constrain it, right?
To develop, to troubleshoot,
right,
to debug,
right.
you
So
need to do it locally.
You pick like a tiny problem or a bit of it, and then you run locally, verify that everything's okay. Then you expand the problem space and you launch it on Golem. So let's do this here. We expect an okay. There is an okay. Perfect. Right. So now let's run it on Brass.
Do you have cache?
I do have cache, yes.
Okay, cool.
We're good. Okay, cool. Right, so whenever you actually launch the app using GeoS on Brass, you're going to be greeted by this beautiful disclaimer, I guess, and a question whether you really want to do this. I think we do, so I'm going to already prepare for yes.
Okay.
Yeah.
So what's displayed here is the config of the Golem network backend, right? So this is also the place to control whether you want to run on Mainnet or whether you want to run on testnet, because that's also the
exactly. So we have Mainnet here. You can, as you said, we can swap it for testnet if you want. Also very good for debugging if you actually want to try the app there. Okay, let's hit enter. You ready? You sure?
Do you want me? Oh, okay.
No, it's fast. Cool. Right. Okay. So we've got the progress bar here. You can also see that the task actually popped up in our Golem GUI, yeah, and everything is there. So we're currently waiting for the nodes. So whenever you launch a task in Golem, you have this 15-second period of like polling. So the node is actually polling for available nodes who wants to do this. Yeah. So there we go, it's finished. Oh my god, it's magic.
The magic of Golem.
See, and it's okay. See that? Okay. Amazing. Everything worked as expected. Okay, so I think it's time to increase the difficulty a little bit. So let's do something more interesting. So especially for you guys, we prepared this really cool app, which is essentially a Mandelbrot set fractal visualizer. So what it means in simpler terms, basically you can generate some cool pictures. But on Golem.
Which fit with the story. Right?
Yes, exactly. I think actually we used some of them in your graphics. I'm pretty sure we did that. But anyway, so everything is on GitHub as well under Golem Factory Mandelbrot. So what we do here, we specify the size of the picture.
No, that's ambitious.
Yeah,
that's ambitious. I know. Okay.
Let's do this. We can do this.
How much time do we have?
Plenty of time. We're fine. Really. So you specify the height and width of the picture in pixels that you want, and how many subtasks. So here it's 1000 by 1002.
Okay, I'm just looking. There's the backend Brass.
Yeah, we're ready. Cool. Okay, again the same pop-up. Let's do this. Right, we got 2 tasks, and it's there. So waiting. Yes. Hopefully it's gonna work. Fingers crossed. It's gonna work. It'll be fine. You don't seem convinced.
At some point, it will work.
It's gonna be magic. You'll see. It's gonna be like poof.
It worked on my machine.
Yeah, I didn't mind it either. Come on, have some faith. Still waiting. There's nothing here as well. Yeah, I'm gonna give it. Oh, there we go. Finished. Wow.
Okay.
Amazing. Right. In this case, we actually generated something, and this is out.png. Do you want to see it?
Yeah. So what you're saying is that it was split into 2 tasks, and each of those tasks computed something which was fetched back
That's
here
correct.
and then assembled together into a PNG.
Exactly.
Cool.
Let's open it up. Oh,
Nice.
I know, it is nice, right?
Okay.
It's very satisfying. I have to say.
Especially that you're not sure if it's going to come back.
You know, the thrill. It's the thrill. It's
It's
amazing.
the thrill of writing something and running. So at this point, we actually got feedback from our headquarters in the workshop. I mean, the missiles are flying. You know, remember?
No, but that's okay.
That's fine. Could you at least try to play along?
But there are no missiles.
Not today. There were. But
Okay.
Then. So we actually realized, the intelligence has realized that that missiles had been launched and they were flying at us at that very moment. But as I said, we were able to, run some countermeasures, and we've deployed a set of a mesh of sensors in the Pacific Ocean, small sensors which were capable of tracking airborne objects. So they were collecting data, they were passing this data over into our headquarters, and our analytics prepared a predictive algorithm which, based on this data, was capable of predicting the impact, time and location. And we had to run this algorithm on our distributed network. And that's what we're actually going to run right now. That's what we're going to do. So the algorithm has been passed to us, the data we've received, but hang on. Okay, so before we actually deploy it to Golem nodes, which are untrusted, we need to do something about it, about the security. Yeah, and the concept here is actually a perfect use case for fully homomorphic encryption, idea. For those of you who don't know, it is an idea of performing computation on encrypted data. So in a sense, we encrypt our inputs for our computation. We send the encrypted input to our distributed nodes, untrusted nodes. We perform the computation on encrypted data, and we get encrypted output as a result. The output we fetch back and decrypt, and we get the results, and we bind them or merge them together. So that's what Kuba is also going to show right now. We got the data has been passed over.
So now we got the data. I just generated it.
Excellent.
Perfect. Right, so let's see this. So this is the data that Mikołaj was talking about. You can explain if you want.
Okay, it's a semi-quasi-random set of points which indicate the distance of a missile from Osaka over time, right?
Oh yeah.
And what we're going to do is we're going to perform a very simple, well, not simple, but linear regression on it. But this is going to be done in WebAssembly using FHE, which
so everything is encrypted. Nobody knows what's inside it.
Experimental implementation of FHE. The guys have prepared precisely for the workshop, and it's going to be run in a distributed manner over Golem. Yeah?
That's correct. Right. So first off, because we want FHE, let's encrypt it. Then let's send it over to Golem Mainnet. Okay, two subtasks. Let's do this. Okay, stuff is happening. And go. Okay, waiting for computation. Now, they should really hurry up. If there was a rocket, you'd probably die. I know. But we were trying at least, so.
Well, we made it back then. So
yeah, but it was
it was an unlimited cluster.
You do realize it's still a story, right? I'm just checking because
it's a nice story.
Sometimes I'm worried you don't.
Nice pictures though.
Very nice pictures, yeah. I think you're helping in computation. Your machine wants to fly out. But anyway, we're waiting. Ladies and gentlemen. We're still waiting. Finished. There we go. Awesome. There we go. Right, so having this, we can actually decrypt. Ta-da. Apply. Actually extract the
And can we view it? Can we visualize it?
Wait, yeah, and then we can plot it. And open.
Okay, so there's the regression.
Can you see the line? This is amazing.
we made it clear, the line I mean. So at this point we were sending the data and the computation results back to the headquarters, and we were switching into the streaming, streamed footage from the headquarters, where we had like live view of those data sets appearing, and we had also live view of the missile flying.
You really do like your rockets.
I like.
That's fine. That's fine. Yeah. Whatever floats your boat, I guess.
But anyway, there you
Oh,
go.
bravo.
The guys made
Well
it.
done.
The guys made it. And I suppose that's the conclusion of our workshop. So, just to recap, you did explain how to write WebAssembly modules on
For GWASM Runner, yes.
for GWASM Runner on using the GWASM package sort of pattern. You did demonstrate how to deploy it on the Golem infrastructure, on Golem Mainnet. Actually,
Remember, you need your client up and running.
and
Well, that's very
you
important.
need to load
so-
up your GNT account as well.
Yes, that's why.
You did see the WebAssembly package executed. You did see FHE implementation on WebAssembly and on Golem infrastructure.
And everything is available online.
That's right. So we hope you liked it. We hope you want to replay this by yourself. Just use the content that we've produced. Just follow the tutorial. Well, maybe without the missiles. Yeah. Anyway, thanks for watching,
I can't believe
and
she asked that.
we would love to hear your feedback. Thank you.
Thanks, guys. Bye.